So a few things need to be understood before we delve into the method of elimination, which is the second technique for solving systems of two equations and two variables, basically for solving simultaneous equations. The first thing you need to understand is the concept of the magnitude of a number. As you can see here, the magnitude of a number is its value when its sign is ignored. Every number, like 2, okay, every positive number is conventionally written without a sign. 2, 3, 4, 5 is the same thing as plus 2, plus 3, plus 4, and plus 5. You need to understand this, okay? Now that you do, let's take a number like 2, which is the same thing as plus 2. What is its magnitude? Well, its magnitude is its value without the sign. Well, it's expressed with this symbol, which involves two vertical lines enclosing the number. So the magnitude of plus 2 is 2, because you just ignore the sign. What's the magnitude of 3, which is the same thing as plus 3? Well, the magnitude of plus 3 is 3. You just ignore the sign. What's the magnitude of minus 3? Magnitude of minus 3 is 3. You just ignore the sign in front of the number. What's the magnitude of minus 4? The magnitude of minus 4 is simply 4. All you have to do is ignore the minus sign. So this is really easy. So let's put it this way. The magnitude of a number plus a, where a is a positive number only, a constant, a positive constant. So a is greater than 0. Let's put it this way. There is any number greater than 0. The magnitude of such a number is a, and magnitude of minus a is also a. You just ignore the sign. I'll do the last one. What's the magnitude of minus 99.99? Simply 99.99. We just ignore the minus sign. Very easy concept. The next concept we need to consider is that deals with the operations on equations. So you're common with mathematical operations like addition, subtraction, division, and multiplication. You know, you can add two numbers together, you can subtract a number from another number, you can divide a number by another number, you can multiply two numbers together. But now we're going to deal with equations. We're going to add an equation to another equation. We're going to subtract an equation from another equation. I'm only concerned with these two operations, but it's just good to know that you can divide an equation by another and you can multiply an equation by another equation. This you would have experienced in expansion. But anyway, we're just focusing on addition and subtraction, applying these operations to equations. That's what we're doing. So here we have two equations. X equals to 2 is an equation. I'm going to call this equation 1. And 3x equals 5 is also another equation. I'm going to call this equation 2. And we're going to perform the operations we're interested in. We're going to perform addition on the two equations, and also we're going to subtract one equation from the other. Let's focus on addition. So adding equation 1 and equation 2 is a simple process, but how do you do it? Well, note that an equation has a left-hand side and a right-hand side term. This equation has a left-hand side term and a right-hand side term. So does this equation. When you're adding two equations, you carry out the left-hand side addition separately from the right-hand side addition, and you equate the left-hand side addition result to the right-hand side addition result. So let's focus on the left-hand side addition. In equation 1, the left-hand side is x, and we're adding that to the left-hand side of equation 2. This gives 4x. The right-hand side addition, in equation 1, the right-hand side is 2. We're adding that to the right-hand side of equation 2, which is 5. That gives 7. So equating the two results, we get 4x equals 7. And that is the result of the addition of equation 1 and equation 2. So nothing difficult about that. Now, we're going to subtract equation 2 from equation 1. So equation 1 minus equation 2. How do you do that? Is a similar procedure. You carry out the left-hand side subtraction. You carry out the right-hand side subtraction. And you equate the results. So carrying out the left-hand side subtraction, let's look at the left-hand side of equation 1, which is x, minus the left-hand side of equation 2, 3x. simplifies to give minus 2x. The right hand side of equation 1 is 2. The right hand side of equation 2 is 5. Simplifying this gives minus 3. So the result is minus 2x equals minus 3. That's the result of the subtraction of equation 2 from 1. But I just want you to note one more thing. When you add two equations to each other, you get one equation. This is an equation. When you subtract an equation from another equation, you also get one equation. So you start with two equations and you're left with one. You start with two equations and you're left with one. So just note that. That'll be useful to you in the method of elimination. Here's another example of an equation and another equation. I want to add equation 1 and 2 together. So the procedure is to carry out the left hand side problem, then carry out the right hand side problem separately, and then equate the results. Left hand side of equation 1 is 4x plus y. Left hand side of equation 2 is 2y plus x. Right hand side operation. Right hand side of equation 1 is 3 plus the right hand side of equation 2, which is minus 1. Simplifying this gives 3 plus minus 1, which is 3 minus 1, which is 2. Equating results gives, I'm just going to do that below. So the left hand side result is 4x plus y plus 2y plus x equal to the right hand side result, which is 2. So all we now have to do is, well, we're done. We've done the addition. We could go further to simplify. By dropping the brackets, we get 4x plus y plus 2y plus x equals 2. This gives 5x plus 3y on the left hand side equals 2. Because if you just bring like terms together, you'd be bringing 4x and x together, which give you 5x. So let me just write that out. Let me just write it out. Bringing like terms together gives 4x plus x plus y plus 2y on the left hand side. And on the right hand side, you just have 2. Simplifying gives 5x plus 3y. Then yeah, that's the result. We've added equation 1 and 2 together. And let's do a subtraction on this side. On this side, equation 1 minus equation 2. Left hand side, subtraction. It's 4x plus y minus 2y plus x. The brackets are so important, I cannot overemphasize them. This is the left hand side of equation 1. This is the right hand side of equation 2. So you're subtracting it. You're basically saying equation 1's left hand side minus equation 2's left hand side. You have to put the brackets. Right hand side subtraction is 3 minus 1. 3 right hand side result of equation 1. 3 minus the right hand side result of equation 2, which is minus 1. And this is 3 plus 1, because minus times minus 1 is plus 1, which is 4. So anyway, equating the results gives 4x plus y minus 2y plus x equals 4. Dropping the brackets gives 4x plus y minus times 2y is minus 2y. Minus times plus x equals minus x equals 4. So we can stop here, but we can also go ahead to simplify. Let's bring like terms together. So if all terms involving x, put them next to each other. Terms involving y together. And simplifying gives 3x minus y equals 4. And that's what we get when we carry out this subtraction. So that's it on adding equations to each other or subtracting an equation from another equation. And you need this when applying the method of elimination. The last concept you need to be familiar with before delving into the method of elimination is the elimination of a variable from two equations. Now we have two equations and it has two variables, x and y. Now if you want to eliminate the variable x, how do you proceed? Well, there are rules concerning this. The first rule is, as it says the following: if the coefficient of a variable, the variable you want to eliminate, have the same magnitude and sign in both equations, subtract the equations from each other to eliminate that variable. If the coefficients of a variable have the same magnitude and different signs in both equations, add the equations together to eliminate that variable. So I'll take one step at a time. Both equations have the variable x. in both equations, so that's equation 1 and that's equation 2. In both equations, the coefficient of x is 5. The coefficient of x in both equations have the same magnitude, and they have the same sign, the plus sign, which isn't shown by convention. Therefore, if you want to eliminate the variable x, all you have to do is subtract one equation from another. So if equation 2 is subtracted from equation 1, the left-hand side subtraction is as follows: 5x plus y minus 5x minus 2y. The right-hand side subtraction is simply 2 minus 7. Equating the result of the left-hand side and right-hand side subtraction gives this equals that. 2 minus 7 is equal to minus 5. So we have 5x plus y minus 5x minus 2y is equal to minus 5. So simplifying gives 5x plus y minus, so minus times 5x minus 5x minus times minus 2y is plus 2y is equal to minus 5. Rearranging by putting like terms together gives expression. So I'm bringing all the x's together and all the y's together, and this gives. This key step here is actually important. So all we've done is obey the rule. We've obeyed the rule. We said we want to eliminate variable x. We noticed that the coefficient of x in both equations have the same magnitude and sign. So we subtract one equation from the other to eliminate x. And during the subtraction process, we get to this stage. And you can see that we're now subtracting 5x from 5x. And this is the only place where x appears. And this is where x totally disappears. X is being eliminated just here. No more x's appear anywhere else once we simplify this, because you get 3y, y plus 2y equals minus 5. All of a sudden, x has been eliminated, and this is the step in which x was eliminated. Well, we're just trying to eliminate, so we're done. So now what we've done is we've started with two equations, which involve two variables, x, and y. We've moved to an equation just involving y. X has been eliminated. So I'll call this equation 3. It's been eliminated. It's all about eliminating a variable. Here's another example. In this example, I would like to eliminate the variable x. Now, the rule says if the coefficients of a variable have the same magnitude and different signs, add the equations to eliminate that variable. I want to eliminate the variable x. Its coefficient is 3 in the first equation. In the second equation, x has a coefficient of minus 3. Magnitude of the coefficient of x in the first equation is 3. The magnitude of the coefficient of x in the second equation is 3, because the magnitude, you ignore signs. So they have the same magnitude. But the signs are different, and the coefficients have different signs. So we're in this situation where the coefficients have different signs. So we have to add equation 1 and equation 2 to eliminate the variable x. So we carry out the left-hand side addition and the right-hand side addition, and we equate them. So I'm just going to do that in one line. In one line, I'm going to do that. Because by now, you'll be familiar with adding equations. So I'm dropping the brackets now. Then rearranging the left-hand side to bring like terms together. Notice, all of a sudden, x disappears. X is eliminated just here, because all the terms involving x cancel out, and we're left with minus 6y plus 2y, which is minus 4y, equals 4. Dividing through by minus 4 gives y equals minus 1, because 4 divided by minus 4 is minus 1. So we now know what y is, but we could have stopped here, but we could have simplified further. But now we have an equation which only involves y. x has been eliminated, and that's all we're trying to achieve. This simplification was not necessary for the purpose of just eliminating the variable x. Here is where x was eliminated. Now say we go back to the original equation, which is, or the equations rather, 3x minus 6y equals 1, and minus 3x plus 2y equals 3. Now this time, I want to eliminate the variable y. I don't want to eliminate x. In the first example, x was the variable we eliminated. In this example, y is the variable we wish to eliminate. So I'm just going to put some kind of border here. Now, the rule says if the coefficient of a variable have the same magnitude, y here has a coefficient of, let's see, coefficient. Y here has a coefficient of minus 6, as you can see. In the second equation, y has a coefficient of plus 2. Now, do they have the same magnitude? No, they don't. And to apply these rules, the first thing is that the coefficients have to have the same magnitude. The magnitude of minus 6 is 6. The magnitude of plus 2 is 2. So there is a technique that you can use to cause the coefficients to have the same magnitude. So consider this. If I multiply minus 6 by the other coefficient, I get minus 12. If I multiply plus 2 by the other coefficient, which is minus 6, I also get minus 12. All of a sudden now, the coefficients have the same value, and they also have the same magnitude, because the magnitude of minus 12 is 12. So, or the magnitude of minus 12 is 12. Let's put it that way. And the magnitude of minus 12 is 12. So if I multiply the first coefficient by the other coefficient, and I multiply the second coefficient by the first coefficient, I get the same value, and I get values which have the same magnitude. So what you do is, whatever you do to these coefficients to make them equal, you also do to the equations. So this is equation 1, this is equation 2. So in order to have equations with the same coefficient, I'm going to multiply equation 1 by what I did to its coefficient, to the coefficient of y there. So I'm going to multiply equation 1 by 2, and that gives, I'm going to multiply it through by 2. So I'm going to multiply each term by 2. 2 times 3x is 6x. 2 times minus 6y is minus 12y. 2 times 1 is 2. I'm going to call this equation 3. But I'm also going to multiply equation 2 by the coefficient of y in the first equation. I'm just going to multiply by minus 6. So let me just reiterate what I'm saying. The coefficient of y in equation 1 is minus 6. The coefficient of y in equation 2 is plus 2. And we notice that when I multiply the first coefficient by the second one, and I multiply the second one by the first one, I get the same result. And I'm doing the same thing to the equations. I multiply the coefficient of y in equation 1 by 2, so I'm multiplying equation 1 by 2. I multiply the coefficient of y in equation 2 by minus 6, so I'm multiplying equation 2 by minus 6. So multiplying equation 2 by minus 6 gives the following. Minus 6 times minus 3x is plus 18x. Minus 6 times plus 2y is minus 12y. Minus 6 times 3 is minus 18, which gives equation 4. So we now have these two equations. So let me just kind of demarcate everything. We have these two equations. In the first equation, the coefficient of y, we examine the coefficients of y, because we're trying to eliminate y. Coefficients. Coefficient of y in the first equation, in equation 3, is minus 12. The coefficient of y in equation 4 is minus 12. Now we have two equations which have the same coefficient, and the magnitudes of this value are both 12 and 12. So now we satisfy the condition where the coefficient of the variable being eliminated is the same in both equations. So now we check their signs. They have the same sign, and the rule says when the coefficients have the same sign, one has to subtract one equation from the other. The coefficients of a variable have the same magnitude and sign, same sign. You subtract one equation from the other, and that's what we're going to do here. So equation 3 minus equation 4 is as follows. The left hand side subtraction is as follows. Again, notice my use of brackets. This is the left hand side term of equation 3. It's the left hand side term of equation 4. The right hand side term of equation 3 minus the right hand side term of equation 4, which is minus 18. Dropping the brackets gives following. Minus times 18x is minus 18x, minus times minus 12y is plus 12y. Minus times minus is plus, so 2 plus 18. Rearranging, bringing like terms together gives 6x minus 18x minus 12y plus 12y. So I'm just swapping the position of minus 18x and minus 12y. 2 plus 18 is 20. Notice minus 12y plus 12y is 0, and y has been eliminated. So we have 6x minus 18x equals 20. And this simplifies to give minus 12x equals 20. So we can stop here or even here, but we've eliminated y. Now y no longer appears. So here's another example, and in this case I'd like to eliminate the variable x. This is equation 1. It's always useful to label equations so that when you refer to them you just say 1 or 2. You don't have to always have to write the equation out. Anyway, we want to eliminate the variable x. So let's check out the coefficients. Let's say coefficient of x rather. In fact, let's be more specific. In equation 1, the coefficient of x is clearly 1. In equation 2, the coefficient of x is 3. The coefficients have different magnitudes. In order to proceed, the coefficients need to have the same magnitudes. This can be achieved by multiplying the coefficients by each other. One times 3 is 3, 3 times 1 is 3. The same idea is going to be applied to the equations. Equation 1 will be multiplied by the coefficient of x in equation 2, which is 3. And we're also going to multiply equation 2 by 1. So whatever you do to the coefficient, you do to the equation. Same thing here. Equation 1 times 3 is as follows. You multiply each term by 3, so x times 3 is 3x. 3 times y is 3y. 3 times minus 2 is minus 6. I'm going to call this equation 3. Equation 2 we multiply by 1. 3x times 1 is 3x. 4y by 1 is 4y. I'm going to call this equation 4. As you can see, the coefficient of x is 3, coefficient of x is 3, and they have the same magnitude and the same sign. So if the coefficient of the variable being eliminated have the same magnitude and different signs, you add. If the coefficient of a variable or the variable being eliminated have the same magnitude and sign, you subtract. So we're going to subtract one equation from the other. So let's say equation 3 minus equation 4. And this gives, for the left hand side subtraction we have 3x minus 3x. For the right hand side subtraction we have 3y minus 6 as a right hand side term of equation 3 minus 4y. So note the use of brackets around the right hand side term of a particular equation. Simplifying gives 0. As you can see, x is eliminated, equals 3y minus 6 minus 4y. So now we've eliminated x, so we can simplify this to give minus y minus 6 if you want. And if I take it a more step-by-step approach, rearranging to put like terms together gives this, which is 0 equals minus y minus 6, and that's an equation where x has been eliminated. So we started with two equations which had x and y, and I just left an equation that just has y. X has been eliminated. And just to reiterate, you notice that the coefficients of x weren't the same, or didn't have the same magnitude. So we said, well, if you multiply one coefficient by the other, as we did here, you can cause them to have the same value. So we do the same thing to the equations. 1 is the coefficient of x in equation 1, and we multiplied 1 by 3. So we now multiply equation 1 through by 3. 3 is the coefficient of x in equation 2, and it was multiplied by 1 here. So we multiply equation 2 by 1. Now we got these two equations, and we subtracted one from the other to eliminate x using this rule. And that's it. Now here's a final example. I'd like to eliminate the variable y. I'd like to eliminate y. let's check out the coefficients, because to proceed the coefficients have to have the same magnitude in both instances of these two rules. So let's see coefficient of y. Equation 1, equation 2. In equation 1, the coefficient of y is 1. In equation 2, the coefficient of y is 2. And they're different from each other. They have different magnitudes. The magnitude of 1 is 1, magnitude of 2 is 2. So the trick is we multiply the coefficients by each other. So 1 by 2 and 2 by 1. So 1 by 2 gives 2, and 2 by 1 equals 2. Now, we do the same thing to the equations. The coefficient of y in equation 1 was multiplied by 2, so equation 1 will be multiplied by 2. Coefficient of y in equation 2 was multiplied by 1, so equation 2 is going to be multiplied by 1, because we want to have coefficients of y being the same. So doing that, we get equation 1 through by 2. We multiply each term by 2, and this gives you 2y equals 4x plus 2. Doing the same thing for equation 2, multiplying equation 2 by 1, sorry, a similar thing, gives 4x equals 2y minus 5. So I'm going to call this equation 3. I'm just going to call this equation 4. Now, the coefficients of y in both equations are the same. So, according to the rules, you are meant to, if the coefficients of a variable being eliminated, so the coefficients of y have the same magnitude and different signs, you add. Here, coefficients of y have the same magnitude and same sign. So we have the scenario where the coefficients have the same magnitude and the same sign. So we have to subtract one equation from the other according to that rule. Now I'm going to tell you that even though this rule says we meet all the requirements of this rule, check out the coefficient of y. It's 2 here and it's 2 here. They have the same magnitude and the same sign. And the rule says we should subtract one equation from the other. But I'm going to tell you now, if we follow that rule blindly, we're going to be wrong. We're not going to be able to eliminate y. And you'll see shortly why. But let's just follow me. Just see. So if we carry out the left-hand side subtraction, I get 2y minus 4x equal to the right-hand side subtraction, 4x plus 2 minus 2y minus 5. If I carry out this, if I simplify this, you notice that y will not be eliminated. And there's a reason, and I'm going to explain shortly. You get 2y minus 4x equals, drop in the bracket, 4x plus 2 minus 2y, minus times minus 5 plus 5. Gives 2y minus 4x equals 4x. Oh, let's put numbers together. So minus 2y plus 2 plus 5 gives 2y minus 4x equals 4x minus 2y plus 7. So let me take all the y's to one side to see if I can eliminate y. So let me add 2y to both sides so I can get rid of 2y from the right hand side. I'll just write it here. That gives so rearranging the left hand side and right hand side to put like terms together gives 2y plus 2y minus 4x equals 4x minus 2y plus 2y plus 7y. So I'll just swap 7 to plus 7 and plus 2y. This gives me 4y minus 4x equals 4x. Here 2y cancels out, so I have plus 7. And if I take all this x to this side, so if I add 4x to both sides, just put all the x's on the right hand side and just have y's on the left hand side, add 4x to both sides, I get 4y minus 4x plus 4x equals 4x plus 7 plus 4x, which is 4y. This goes to 0 equals, so 4x plus 4x is 8x plus 7. So if you just rearrange and put like terms together on right hand side and simplified, you get this. As you can see, y has not been eliminated, and there's a reason, and I'm going to tell you why. But just notice there's still y present and there's still x present, but we follow the rules. So what went wrong? So let's start the problem again. Let's start from the beginning to see what went wrong. Initially, we have two equations, equation 1 and equation 2. We're going to try and eliminate the variable y. In terms of coefficients of y, in the first equation, coefficient of y is 1. Second equation, coefficient of y is 2. So we multiply the coefficients by each other. This gives 2 and this gives 2. And doing the same thing to the equations gives equations where the coefficient of y have the same magnitude. As you can see, multiply equation 1 by 2 because the coefficient of y in equation 1 was multiplied by 2. The coefficient of y in equation 2, which is 2, was multiplied by 1. So we're going to multiply equation 2 by 1. See, doing that, following these, you get 2y equals 4x plus 2 from this, and from multiplying equation 2 through by 1, we get 4x equals 2y minus 5. This is equation 3. This is equation 4. Now, if we re-evaluate the current equations, or if we evaluate the current equations 3 and 4, the coefficient of y here is 2, the coefficient of y in equation 3 is 2, the coefficient of y in equation 4 is 2 as well, as you can see. So what we did was then jump to the rule, which says so the magnitude of this coefficient is 2, the magnitude of this coefficient is 2 as well. Then we jump to the rule, which says the coefficients of a variable being eliminated have the same magnitude, which they do now, and sign, subtract. They do have the same signs, but this is where we went wrong. Now, in order to actually apply that rule, the variable being eliminated must appear on the same side of the equation in both equations. So let me demonstrate that. In equation 3, the variable y, which is what we're eliminating, appears on the left-hand side. In equation 4, the variable y appears on the right-hand side. In order for these two rules to apply, the variable y must appear on the same side of the equation. So I'm going to write equation 3 again. I'm going to write equation 4. But this time, I'm going to swap the left-hand side term with the right-hand side term so that the term containing the variable y now appears on the left-hand side term. This gives 2y minus 5 equals 4x. So now, y appears on the left-hand side in equation 3, and y only appears on the left-hand side in equation 4. So the rule is that before we go and use these rules, the variable being eliminated must only appear on one side of the equation, and they must appear on the same side in both equations. So you need to remember that. So I think you should note that down. The variables must appear only on one side of the equation, and they must appear on the same side of the equals to sign in both equations. In this case, y appears on the left hand side. In this case, y appears on the left hand side. And we achieved this with equation 4 by just swapping the left hand side and right hand side, because that's allowed. This equation says 4x is equal to 2y minus 5. All we're saying is, well, 2y minus 5 is equal to 4x. I mean, if you think about it, if I tell you that A is equal to B, it also means that B is equal to A. If 2 sweets equals 2 sweets, then 2 sweets equals 2 sweets. If two things are equal, then they're equal to each other, regardless of the way you decide to, regardless of the order in which you state the equality. Examining the coefficients of y in the current equation, so equation 3 and 4, reveals that the coefficient of y in equation 3 is 2, which has a magnitude of 2. The coefficient of y in equation 4 is 2 and also has a magnitude of 2. So the coefficient of y in both equations have the same magnitude. The coefficients of y also have the same sign, plus 2 and plus 2. So for the case where the coefficients have the same magnitude and the same sign, we subtract one equation from the other. But you have to remember that these two rules apply when the variable being eliminated appears on the same side of the equal sign in both equations, and only appears on one side of the equal sign. So there are two things. Anyway, now carrying out the subtraction, equation 3 minus equation 4 will cause the variable y to be eliminated, looking at the left hand side, we have 2y minus 2y minus 5. And the right hand side subtraction gives 4x plus 2 minus 4x. Simplifying gives 2y minus 2y plus 5 equals 4x plus 2 minus 4x. As you can see, y doesn't appear on the right hand side, but only appears on the left hand side. So we're left with 5 equals 4x plus 2 minus 4x. But I must say that further simplify this expression, you get 5 equals 4x minus 4x is 0. You get 5 equals 2, which is not a valid result because 5 is not equal to 2. But you don't need to worry about that because the particular equations chosen were chosen just to demonstrate how you could eliminate a variable. And that's all you need to focus on, the elimination of a variable. And the technique is to use these two rules. You make the magnitude equal and you check whether the signs are equal or different. If the signs are equal, you subtract one equation from the other. If the signs are different, you add the equations to each other to eliminate the variable. But the key thing you need to note before you apply these rules is that the variable being eliminated, if it appears on the left hand side in one equation, it must appear on the left hand side in the other equation. If the variable being eliminated appears on the right hand side in the first equation, it must also appear only on the right hand side in the second equation in order to use these two rules. That's just the key thing, and that's it with elimination of variables. Now we're going to move on to the method of elimination, which is now going to be very easy given all these concepts you've just learned.